Hello everyone, let's try straight into virtual tables. The formal definition of a virtual table is a custom entity in Dataverse that has columns containing data from an external data source, allowing that data to appear as if it lives locally without actually moving or replicating it. In plain everyday English, it is like a magic mirror. You are looking at a table in your app, but you are actually seeing data that lives somewhere else entirely, like an old SQL database or an Excel sheet on a different server. Imagine you are running a local hardware store. You have all your customer info in Dataverse, but your inventory is kept in a 20-year-old system in the back office. Instead of manually copying thousands of rows of data every morning, which is a nightmare, you create a virtual table. Your app thinks the hammers and nails are right there in Dataverse, but they are actually staying right where they have always been. Stay with me here because this is how we connect the old world to our new intelligent world. You've probably seen this at the office where you have to log into 3 different websites just to check one order. Virtual tables fix that. Let's break this down together. We are building a bridge so our data can stay home but still show up for work. So now that we've mastered the idea that data doesn't have to move to be useful, you might be wondering how that magic mirror actually communicates with the outside world. Well, that brings us right into our next step, which is data providers and connectors. This brings us to virtual table data providers. The technical definition describes a data provider as a software component or plugin that facilitates the communication between Dataverse and the external data source, handling the translation of queries and data retrieval. To speak naturally, it is the translator. Dataverse speaks one language, and your old SQL database or SharePoint list might speak another. The provider sits in the middle and makes sure everyone understands each other. Imagine a dummy example. You are at a restaurant in a foreign country. You are Dataverse. The kitchen is the external database, and the waiter is the data provider. You tell the waiter what you want in your language, he translates it for the chef, and then he brings the food back to your table. You've probably noticed at the office how some systems just don't talk to each other. That's usually because they're missing a good translator. We can use pre-made OData providers or even build our own if we have a very unique system. Let's break this down together. The provider is the engine that makes the magic mirror work. So, now that we have mastered how the translation happens, you might be wondering how we actually set up the glass of that mirror so it shows the right columns and rows. Well, that brings us right into our next step, which is mapping external metadata to Dataverse tables. Now we need to talk about metadata mapping. The formal definition says this is the process of aligning the schema of an external data source with the table and column definitions in Dataverse, ensuring that data types and identifiers are compatible. In simple everyday English, it's matching the labels. If your external system calls a column client ID and Dataverse calls it account number, you have to tell the system, hey, these are actually the same thing. Imagine a dummy example of a library. You are merging two different catalogs. One uses author and the other uses writer. You just draw a line between them so the computer knows they both mean the person who wrote the book. Stay with me here because getting the data types right is critical. You can't map a column full of words to a column that expects numbers or the mirror will crack. You've probably seen this at the office when you try to upload a file and it gives you a format error. Mapping prevents that by making sure the pipes fit together perfectly. Let's break this down together. Mapping is the blueprint for a data bridge. So now that we've mastered how to match our labels and align our pipes, you might be wondering if we can actually change the data through this mirror or if we are just allowed to look at it. Well, that brings us right into our next step, which is CRUD Operations and Performance. This brings us to CRUD Operations, which stands for Create, Read, Update, and Delete. The technical definition defines these as the 4 basic functions of persistent storage that can be executed on virtual tables, depending on the capabilities of the underlying data provider and source. In plain language, it is look but don't always touch. Sometimes a virtual table is read-only, meaning you can see the inventory but you can't change the price from your app. Other times, it's full access, where a change you make in Dataverse happens instantly in that old back office system. Imagine a dummy example. You are using a weather app. You can read the temperature, but you definitely can't update it to be sunnier. However, if you are managing a staff list, you'd want to be able to update a phone number. Stay with me here, because every time you look at a virtual table, Dataverse has to go fetch that data in real time. If the external system is slow, your app will feel slow too. You've probably seen this at the office when a website takes forever to load a report. That's a performance bottleneck. Let's break this down together. We have to be smart about when we virtually connect so we don't slow down our intelligent foundation. So, now that we've mastered the rules of looking and touching data across the bridge, you might be wondering how the AI uses this external data to make smart decisions. Well, that brings us right into our next step, which is AI integration and relationship mapping. Let's dive into relationships with virtual tables. The formal definition describes the ability to create lookups and associations between native Dataverse tables and virtual tables, allowing AI models to traverse distributed datasets as a single unified graph. To put it very simply, it is connecting the local to the remote. This is where the real intelligence happens. Imagine a dummy example. You have your customer data living natively in Dataverse and your past purchases living in a virtual table from an old SQL server. You create a relationship between them. Now, your AI assistant can look at a customer and say, aha, based on their virtual purchase history, I recommend we send them a coupon for cat food today. The AI doesn't care where the data lives. It just sees the connection. You've probably noticed at the office how powerful it is when a tool suddenly remembers your history. That's the power of unified relationships. Let's break this down together. We are using virtual tables to give our AI a much bigger brain without the cost of moving all that data. So now that we have mastered how to link our local data to our remote mirrors for the AI, you might be wondering how we keep this whole bridge safe so hackers can't sneak across it. Well, that brings us right into our next step, which is security and authentication for virtual entities. Finally, we reach security and authentication. The technical area involves configuring the credentials and permissions required for Dataverse to securely access the external data source, often using service principals or user-level impersonation. In our relaxed classroom tone, it simply means the passport control. Just because you built a bridge doesn't mean everyone can walk across it. The external system will ask, who are you and why are you looking at my files? We have to provide the right secret handshake, like an API key or a username, so the connection stays private. Imagine a dummy example of a bank. You might have a virtual table showing account balances, but you only want the manager role to see it. If a regular clerk tries to look, the bridge says access denied. You've probably noticed at the office how important it is to keep sensitive data under lock and key. Virtual table security ensures that the magic mirror only reflects what you are allowed to see. Let's break this down together. As intelligent app builders, we are the gatekeepers of this bridge. We've looked at the magic mirror, the translator waiter, matching the labels, the rules of touching data, the AI's bigger brain, and finally, the passport control. We've mastered integrating external data with virtual tables. You now understand how to make your foundation reach across the whole company. Well, that brings us right into our next chapter.